Welcome to the Red Horizon Podcast, Episode 2. I'm today's host, migrev-dolseg, and I'm here today with nomryg-nilref, also known as Jack Fox. Jack, thank you for joining us.
Yeah, thank you for having me. This promises to be fun.
Before we get started into the interview, brief introduction if you're not aware about what Red Horizon is. Red Horizon is an Urbit hosting platform, and our goal is to make getting on Urbit as simple as possible. First question, Jack, how'd you get into computers? What is your relationship with personal computing? And tell us a story about how you ended up in Urbit.
Wow. So how far back should I go? So growing up, even in the 70s, my father knew that computers were going to be a big thing, and I didn't care at that point. I remember when I was in high school, the math department had a classroom that was the math lounge. And there was actually a teletype terminal that was connected to a mainframe at Stanford University. There was like a young math teacher who knew how to use it. And so he passed it on to some students. And so that was actually my first exposure to any kind of computer. So I think I sat down at it a few times, and I think there was actually a Star Trek game. You had to type stuff in and it would type stuff back out at you. It was actually a typewriter thing. And it also had a paper punch tape, which some people knew how to use. And I guess some kids actually wrote some very simple, basic programs. I never learned how to program on it, and it was kind of interesting. And then fast forward to my college days, and I took one class that I ended up dropping, which was a statistics class that we had to do punch cards for. I actually went through that one assignment and created these punch cards to do something like calculate the standard deviation of some statistics, something you could actually do by hand, but you had to use the punch cards. I also took a tour of the computer center at college. They demonstrated the future, which was a CRT terminal that would actually show you what you were typing, and you could make the typing corrections. I was like, oh boy, because I hated using a manual typewriter to write papers because you always had to make corrections, and I was a terrible typist. So I thought, oh, that's actually interesting. So then there's like a 3-year hiatus in which I became a exchange student at a university in Germany and lived in Germany for a couple of years, wandered around Europe and the Middle East for another year. So I was gone for 3 years outside the country. And in that time, everything changed. So I came back after 3 years in 1982. There were these strange advertisements on television I'd never seen before for like fax machines, and personal computers were just starting out. Apparently they were very primitive. I still didn't have access to one. Came back to this country at the height of the 82 recession, which was like the worst time possible to try to get an entry-level position in anything. A friend of mine suggested, why don't you learn programming? So I went to night school at the College of San Mateo and eventually got far enough along. So I got hired by EDS, which was Ross Perot's company. And they trained me on mainframe programming. That was interesting. I actually liked coding in IBM 370 assembler. It was fun. For one thing, all your memory was in one place. So it was really easy to debug. And there were no levels of abstraction because you're dealing with the assembler. And the debugging was super easy compared to COBOL, which before automated debuggers came out was just a real chore to debug in, because you had to remember pointers to pointers and which pointers pointed to what pointers. Anyway, it was very complicated. And I didn't take good notes in class on how to debug. So, and I didn't code any COBOL for like about 2.5 years after that, or almost 3 years. So I was happily coding assembler, and then I started coding COBOL again. It's, oh shit, when this crashes, debugging it is a real pain. Yeah. Anyway, fast forward a lot more years and did a lot of mainframe, eventually got into kind of more Microsoft oriented personal computing. And everything started happening in JavaScript, in browsers. This was a new concept. Okay, we've got another level of computer complexity intermediating between what I write on the back end and what it displays for me. So this is about the fourth iteration of online interaction that I had dealt with. So that's been like the story of anyone's life who's had a long experience in this industry. Is you just see a new way to do the old thing over and over again. It gets tedious. Fast forward way fast until I started getting interested in Urbit. And the thing that stuck out most of all was, rationalizing the entire stack, designing it from first principles rather than just adding another hack onto the last bunch of complexity that somebody came up with to reinvent a new way of doing something that we always did before. Was that too long-winded? That's a real brief overview of how I got into this.
No, it's good.
Area.
It's inspiring that there's people who have as much computing experience as you. You've seen all these different progressions in the history of computing. And to have people like that in the Urbit ecosystem, to me, gives it a little bit of a vote of confidence. Someone who has real world experience thinks that this thing is better. One of my favorite questions to ask people who are into Urbit is, what about this system is compelling to you and beautiful? And how do you describe your relationship with Urbit?
What's compelling and beautiful is designing things from first principles and taking advantage of all of the computer science that's been learned since the 1950s. Hopefully, this will make computing a little more human than it's been, because when I first came into the business, actually, easily a third of all the programmers were women. And the reason that has changed, I believe, is that things have just gotten more complex. When I first got my first job in the industry in 1983, it was a job. And this is a way in which women actually, I think, are smarter than guys in a lot of ways. They approached it as a job, and they continued to approach it as a job. But the harsh reality as we got into client server, and first there was the personal computer, and then on the business side, that didn't really work so well because enterprises need much more integrated computing than just a standalone thing that sits on your desk. And the only way of interacting with other computers is to put something on a floppy disk and walk it over to the other computer. There was always networking from way back at the enterprise level. And the thing about this was that it took a lot of self-education to learn how to do these things. Sometimes there would be corporate education that would give you some clues, but the pace of development was so fast. It's like the Macintosh came out with its GUI, and then they had some weird system of cards to program interactivity with that, which, I think that scheme got abandoned pretty fast. But then the next scheme came along, and then the next one, next way of doing this. And then client server became a big buzzword. But you were constantly having to upgrade your skills and learn new ways of doing this. Some guys really gravitated to this and became a lifestyle, which is, I'm not sure entirely healthy, maybe it isn't, but I think it's the biggest reason in a way how women dropped out of the computing workforce. Probably my first 5 or so bosses, 3 of them were women, I'm sure. It was really common for women to be first line managers as well.
Talk to us a little bit about the social aspects of community software communities. And what I mean by that is you can have a really great technology, but the community behind that technology is arguably just as important for the development and the implications of that technology in the real world. How do you see the Urbit ecosystem, which is very male dominated and has some interesting social aspects to it, to say the least? What advice would you give to the Urbit community on a social level?
I think the Urbit community on social level is doing pretty well. Everybody I've interacted with is pretty polite. You get a few trolls on some of the groups sometimes, usually as comments, right? The anonymity of online interaction is both a blessing and a curse. It provides for some benefits, but it also has a tendency to give immature people the wrong impression of how to interact properly with other people in an online setting. But I think the urban community is pretty good. Most of the people are very curious. So that's one of the hallmarks of a good, healthy online community, I think, is curiosity. So not just in the things, the topics that motivate all the people in the community, but also that you're curious about totally unrelated things. And this is also interesting to other people in the community. And in that sense, I think Urbit has built a pretty healthy community. It's mostly people who recognize the need to reinvent the computing stack in a more tractable form that we can all appreciate and use for our own personal productivity, which I think was the original underlying motivation for most technology enthusiasts. But then they quickly get enamored with the tooling, and that becomes the focus of what you're interested in. And that's what, individual contributors can contribute back to the community, is working on tooling, which seems to be where we are currently. There's still so much to be done. It never ceases to amaze me that so much has already been done, but yet there's still a lot more till we get to that kind of Urbit 1.0, which Ted talked about in his talk at the reassembly. I don't know if you've had a chance to see that one yet.
Yeah. So you touched on something that I want to talk about a little bit, which is this ethos in Urbit that it's okay to start over from scratch, and this willingness to take a deep look at the existing software stack and say, okay, Linux is insufficient for what we need to do with computers, the relationships we want to have with our computers. We're going to throw out all of Linux. We're going to throw out all of the C language. We're not going to use Intel chips, or we're not going to rely on the assumptions that Intel chips rely on. We're going to be okay with starting over. And you're working on what I think is a pretty important project in the Urbit ecosystem, which is a relational database. So before we get into a little bit more of a technical conversation about your relational database, talk a little bit about what it's like subjectively to think in terms of, okay, we're going to reinvent this thing. Like SQL, there's problems with that. And you're one of the people who's saying, I think I can fix that. And it takes some bravado. I think it's pretty cool.
Let me first start by addressing, even though we would like to do away with Intel, and we would like to do away with the C language, and we would like to do away with Linux, all these things are still a necessary substrate for Urbit, right? Urbit is, as it exists today, is a VM, and it works best on top of Linux. In fact, it really only works on top of Linux right now, right? Because the underlying Mac OS, to my understanding, is basically Linux, and there's no longer a Windows implementation. Most of the chips it runs on are Intel chips, I believe. I think there is an implementation for AMD, but not certain about that. Then skip you to SQL, which was the main part of your question. SQL was a thing that was nearly invented, right? So we just needed to make a few corrections to it. And I think this is a standard Urbit way of moving forward. I don't know that much about the internals of Urbit, but I think like in networking, I guess the original core developers working on this just stripped down all the ideas of networking to the most basic ones. And Curtis asked the question, why can't we just have guaranteed one-time delivery? That was a big kind of an innovation in a way. It definitely causes other things to worry about, but I think the trade-offs are well worth it. Having guaranteed one-time delivery, one and only one-time delivery of messages is a huge step forward.
Why is that important, actually? Like, I would assume that functional programming languages, we're going to focus on idempotence. If we get spammed by packets a million times, it doesn't really matter. What is the significance of exactly once delivery?
It simplifies the networking stack. From the very beginning, there's been problems with interacting with other computers. The problems with interacting over a network, the noisiness of the network, the reliability of connections. There's just so much stuff that, for the most part, application programmers historically have had to worry about. All the things that go wrong aren't handled at the networking level or at the OS level. They're handled at the application level or pretty close to the application level. And that just adds a lot of complexity. It makes you have to be an expert on whatever protocols you're using to do these connections and these message passings. And ultimately, it leads to you have to figure out some sort of retry logic, because the way sockets work, and I don't know that much about them other than the fact that they're a pain to deal with, is you basically are responsible for making sure that you actually communicated to the people that you think you communicated to, or the computers you think you did. So that's just another example of a whole bunch of complexity you need to be dealing with at the application level. We'd like to be able to abstract this all away and have another level of the system take care of it, which is what Urbit does.
Give us an overview of first relational databases as a concept. What's the benefit of structuring your data this way? And a little bit about the implications of that for Urbit. Why hasn't it been written for Urbit so far? Does it really matter? Why are you working on this?
Big question. I'm working on it because it's something I know. So it's something I think I can contribute back. I've been working in relational databases since 1989. They've also suffered, just like the networking example I gave you, they have suffered from a similar problem, which was the relational database technology was conceived of and released into the wild before computers were really powerful enough to use it. What is relational database technology? Basically, it's a means of decomposing the data in relatively large scale systems, although it could be as small as a contact manager, for instance. And it's intuitive that there's relationships between different forms of data within whatever domain you're working in. There's a formalism to this, which I don't want to get into because I am not good at explaining it. But to simplify it as far as possible, you decompose everything into standalone two-dimensional tables that exist of rows and columns. So the columns are a set of elements that can exist for each row or each record, if you will. And there's always a unique key, which ideally is a natural key. And by a natural key, I mean that it's data that already existed within the system. For instance, the key to your contacts table could be pat P, But another entry in the context table could be your first and last name, your physical address, your email address, all sorts of things like this. In some cases, any one of those could be standalone records all by itself. So extending the metaphor a little bit, you could have one table just of maybe it's keyed off of your PAT-P, but then it gives you your email address. It could be the email address table. That's a very simple example. And in reality, you might not want to break it out that far, but I hope that kind of gives you a feeling for what I'm talking about. So all these tables, which are these two-dimensional things of columns and rows, have their own keys to them. And then there's frequently foreign keys involved, which means, for instance, that PAT-P could also be pointing to something else, or what's a good example? The city you live in, there could be another table of cities that have got related information, cities with them. It's a means of organizing a lot of data. You could have the city information, which really doesn't have that much to do with you personally, but if the system wants information about the city because they want to know where the nearest Chuck E. Cheese is in your city, your system does that. There's this way of organizing data along the lines of organizing it as tables. So there are theoretical reasons why this is good, because it allows you to mix and match your data in all sorts of interesting ways with confidence. The downside is it does take a little bit of mental effort to think through how to organize it to begin with, which is where I think NoSQL caught on for two reasons. One of which was you no longer had to think through how to organize all your data in tables because you could just have one giant record, which had some advantages. Mostly, hey, your record works for the one standalone thing that your application is actually doing, which is fine. And in a lot of cases, completely meets the needs of what you're doing. But if you ever want to expand, or if you ever want to use your data for things that you hadn't thought of for this particular application, you're locked out because this one size fits all bespoke data schema that you have is not flexible enough to answer other questions. So you can't ask arbitrary questions of your data. You can in a SQL database.
So what are the implications of this for Urbit, which theory boasts this idea that all your apps are composable and the data is all yours and you can do whatever you want with your data?
I think it moves towards making that a reality. With the project I'm working on, any project that implemented the urQL language as a front end would now be composable, because depending on the lengths to which it is fully compatible, you could ask arbitrary questions then of any particular app and mash that together with queries asking arbitrary questions about another unrelated app. One of the things I hope to promote is the urQL language is already pretty far ahead, and it exists of a parser and an AST. And the AST, or abstract syntax.
Tree?
Tree, yes, thank you. There are already a couple of other bespoke database implementations that are claiming some level of relational database technology. So this is very exciting already, because any of these can implement to the extent that they support anything in urQL easily by just snapping on the parser and the AST. The parser will parse any urQL strings into the AST, and then you can use the AST to translate it into your own AST, and away you go. That's my hope, that other databases and other bespoke data stores can actually start implementing urQL now.
Well, what does urQL look like? Because a lot of domain-specific languages in Urbit model to Hoon's very unique tree structure with blocky runes, like sail is the example that comes to mind. Have you done anything like that with urQL, or does it look basically like SQL?
It looks very much like SQL. In fact, it is very much like SQL. So the story goes that when Cod was working on relational databases in the 1970s, there was another project which created SQL, or he was involved with it somehow, but he just saw it as a prototype of the eventual query language. He didn't think it was ready for prime time, but for some reason, IBM marketing wanted to push it out the door, which I don't really understand because, like I said, at the time, computers weren't really powerful enough to use relational databases yet. So that was a bit premature, but it locked in a bunch of bad habits in SQL. So among them are null values. So that's one thing that urQL gets rid of. No null values anymore. You can't define tables that allow null values. And when you do outer joins, which, as I point out in my talk that I gave at reassembly, outer joins are actually a macro of what is the real theory in relational databases. They're a macro in the sense that joins can only work positively. We can join this row from this table to that row of that table because they've got one or two columns that have got the same value. That's how joins work. But outer joins say, okay, we want that, which we just talked about, which is a join. Plus, whenever the two tables do not join up, we want to always return the one from the first table or the row from the second table without its joining partner, because there is no joining partner. And what this actually is, it's a union of a join, which we just talked about, and everything that doesn't join. So it's a macro in a sense. So that's another thing that we take care of, because in SQL, it depends on null values to work with outer joins. urQL does it differently. It relies on type theory. In other words, the rows that successfully join are one type, and rows that do not join, but we still want to include, are another type. And that's pretty easy to see just by observation. It is that one row has got columns that one row type has columns that the other row type doesn't have. Yeah, we're still able to work with these through strong typing. There's a few other composability things that I do, one of which is I've outlawed inlined subqueries, which are a holdover from very early SQL for the most part, but people still use them, and it makes the SQL very unreadable. So they either put a subquery like right in the select clause for a column, which gets really, really ugly, or they put it in the predicate. For instance, you might want to do a predicate on where a column in some table you're selecting from is, the value is in a list, which you have to define with another query. And typically what you do is you inline this subquery right in the predicate for SQL. But in urQL, we actually have another clause that lets you define it separately. So it's like another standalone piece of query code that you can look at, and then it's aliased, and you actually use the alias instead of the entire query. So it makes it easier to read, makes it more obviously composable in that sense. And then also the other composability options that are already available in SQL are also still available. It's not throwing out SQL entirely. I think it's fixing the parts that are broken with it. And what this all leads up to that's really big is that urQL only ever returns proper sets, which is not the case in SQL. It's very easy to have duplicate rows. In fact, you can create base tables that have duplicate rows in them, which is amazing. And that's because SQL doesn't require you to have a primary key on base tables, which is just bizarre. So that's another thing we fix in urQL is, every base table is going to have a primary key, period. So that means everything is now a set. So no more duplicate rows.
And what are some of the synergies between a system like this and Urbit? Is Urbit amenable to building query languages? Is it performant? What have you found by trying to implement this?
I think performance is going to be okay-ish, even now without the Aries project going live. So I've already loaded a pretty decent demo database that's, I think, around 45 meg of data. And it loaded on my faster machine in 90 seconds, which isn't great, but it's not terrible either. And if the promises of Aries come true, that it actually is 100 times faster, or even 10 times faster, if it went down to only 9 seconds, that would be even better. But I suspect that when Aries comes out, performance is going to go way up. And the other thing I'm finding is that because Hoon is a tree-based language, the primitives in Hoon, especially things like ordered maps, they are the thing that a query language wants to have to be built out of. I'm really pleased with how the progress has gone and how it appears, although I haven't finished it yet, but it appears that things will work out quite well and they should actually be pretty performant.
Do you see this being used in every application, just applications that have lots of data? How do you see that?
Ideally, I would like everyone to have at least some implementation of urQL for their bespoke data store, or use the Obelisk data store, which is what I'm working on. It's not available yet, but that will be coming out, which will implement everything in urQL. Reason being is I just think since this is a personal server, there's just going to be a lot of information locked up in individual stores that more likely not at some point, there's going to be good reason to mash it up. Why not create the tools that let you do that? Everything should be accessible in this manner, ideally. You want your data to be accessible to you, right?
Exactly.
And there's also a permission system. So while you can do queries across ships, you're in full control of what kind of permissions you want to grant to other ships and eventually other agents. I think agent sourcing is going to be available as of Kelvin 412, I think. Crossing my fingers to see what happens. It's coming out soon.
We're all crossing our fingers for these Kelvin decrements. You mentioned Obelisk. What is Obelisk and how does it fit in to urQL?
Okay, Obelisk is the actual query engine that I'm working on. So urQL is just a query language, okay? It takes this SQL-like script and parses it and puts it into an AST. Obelisk then takes the AST and actually performs whatever, creates data schemas from the DDL or data definition language part of urQL. There's also the data manipulation language part where you can insert data, you can update data, you can delete data. And the pure query part, which is what we're mostly talking about, is another subset of the entire urQL language, right?
Awesome. Before we sign off, I got a few more fun questions for you. What are some of your favorite Urbit apps at the moment?
My favorite are Groups and Talk for sure. I'm trying to get Quorum going again. I guess there's a beta, and I think I've installed the right stuff, but I haven't looked at it too closely since I did this a couple days ago. So what I had before was just old Quorum, and one or two groups had set up some Quorum databases or whatever they are. I'm curious to see how it works now. One that's peripherally related is Vienna Hypertext, which I haven't used yet. I need to buy a subscription, but I don't think it fully integrates with Urbit yet, but I believe that they're intending to. So looking forward to working with that one.
Do you have any favorite groups that you're in? So you'd recommend people to?
I mostly deal with the technical groups. So like battery payload is a good one. Forge is another good one. I used to look at Hooniverse a lot, which is also a good one, by the way, but I just decided to make battery payload and the Forge kind of my go-to ones simply because there's too many to keep track of. And then for pure like socializing, there's a few others that I keep track of on local and the Bay Area local group. There's a few other. Native Planet, I keep track of that since I do use Native Planet.
Awesome.
So it's another thing I'm looking forward to their next release. Should be interesting.
Yeah, I've heard they've got a new one coming at Assembly. It's very exciting. Jack, thank you so much for coming on the Red Horizon podcast. Your experience and your expertise does not go unthanked in the Urbit community. So continue to share your expertise and build awesome things. And to the audience, thank you for listening. We'll see you next time.
Thanks, Will. It was a pleasure.